Day 82 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. This time we're at day 82. Hope you guys have been keeping up with the channel so far. We're in the bit manipulation part of the LeetCode 75. In case you're wondering where we at, we're almost done. We're almost done with the LeetCode 75, guys, so I hope you're excited about that. Hope you guys aren't losing any discipline or any motivation because we're just getting started and we have a long way to go. But, however, before we get started with this question today, don't forget, guys, bring a mouse right over here and click that subscribe button for me, guys. And after you click that subscribe button, go ahead and smash that like button for me, guys. Then after you smash that like button, I'm calling all of my bankers. I need all of my bankers to the comment section right now, and drop two bank emojis in the comment section so we can help run this engagement up and we can help spread this content to a broader audience and get more people interested in Swift and learning how to write code and do LeetCode in Swift, guys. We're trying to help build, we're trying to do our part in helping to build this Swift community, guys. And hey, we're going to learn and have some fun at the same time. So today we have question number 136, single number. The difficulty level is easy, guys, so don't worry. We're going to keep the solution as simple and easy to understand as well, because we're all trying to learn and there's no point in writing code that nobody understands. So before we get to the fun part, though, let's see what the question says. It says, given a non-empty array of integers, nums, every element appears twice except for one. Find that single one. You must implement a solution with a linear runtime complexity and use only constant extra space. So let's look at the examples. It's pretty self-explanatory, but we're going to go through them anyway. We have example 1, the input nums, array of integers 2, 2, and 1. The output is 1. The output is 1 because we want to return the element that appears only once. So every element appears twice except for 1. That's the one we want to return. In the example 1, the 2's appear twice, so we want to return the 1 because the 1 only appears once. So let's look at example 2 because it has a little bit more integers that we could work with to really understand what it's asking. So in example 2, we have the input nums, an array of integers 4, 1, 2, 1, 2. In this case, the 1 and the 2, they both appear twice. So we have a 1 right here, the 1 right here, we have a 2 right here, and a 2 right here. However, the 4 only appears once, which is why the output is 4, because we want to return the element that only appears once. Then we have example 3, nums is an array of integers, just one element, 1, and the output is 1 because even though there's only one element in the array, that one element only appears once. So we're going to return that one element, and which in this case is 1. So now that we know the question is asking, guys, it's on to the solution. And guess what, guys? We got a one-liner. So get excited about that. We're going to keep this quick, simple, and easy. It's only one line of code. I'm going to break the code down to you, though, because I know if you're just getting started with bits and bit manipulation, a lot of this stuff can look foreign, like a foreign language that you've never seen before. So we're going to go through that too as well, guys. So don't worry about it. But first, let's get to the code. The first thing we're going to do is we're going to just say nums dot reduce. Then we're going to open up the parentheses. We'll say dot 0, comma. Then we're going to put this little upward caret sign right there. And that upward caret sign is the exclusive OR operator for exclusive OR, the bitwise exclusive OR operator for when we're dealing with bits and bit manipulation. It's similar to the AND operator, but it's kind of like the opposite of the AND operator, and I'm going to show you why. So in this case, say we're comparing the numbers 1 and 2, right, where 001 would be 1 and 010 would be 2, right? So what this does is, instead of comparing these two numbers, and since they're different, or since they're the same with this one, it's going to return a 0. Then when they're different right here, so this is 0 and this is a 1, it's going to be a 1 because they're different. And this is a 0 and this is, and this is a 1 and this is a 0, it's going to be a 1, and the output would look something like this. Let's do another one so we could really bring this home and y'all can understand. But it's basically the opposite of the AND operator that we used yesterday. So let's do another example so we can see. So say we're comparing the 3 and we're comparing 4, right? So in this case, the output would be, since this is 0 and this is 1, since they're different, the output would be 1, right? And then since this is 1 and this is 0, it would be another 1. And since this is 1 and this is 0, it'd be another 1. And the output would look something like that. Whereas compared to, say we had, let's say we had something that had the same numbers, right? So let's say we're doing comparing 0 and we're comparing 1, right? So in this case, the output would be, since these numbers are the same, then we put this would come out as a 0. Since these numbers are the same, it will come out as a 0. And then since these numbers are different, it will come out as a 1. So that's how this exclusive or bitwise operator works. It also has a unique property where, so it would be A, say we do A or exclusive or operator A, that will come out to 0, right? Say we did A exclusive or operator 0, that would come out to A, right? And using this property right here, that is how we are able to cancel out the doubles in the array over here, right? So say it went like this. Say it went 1 or operator 1, the output would be 0. And say it had 2 operator 2, right? The output would be 0. But say it had 4, we're looking at example 2, excuse me guys, just so y'all know. And say it had 4, then it had the OR operator 0, then the output would be 4. So that's how we're able to loop through this array and find the duplicates, because of how this operator works. So with this one, so we would start off right here. I mean, we're looking at example 2. So basically, let's delete this, but we're looking at example 2. It go boom, boom, boom. The output would be 0. Then it go, say we do boom, boom, boom. That output would be 0 as well. And say we do 4, boom, excuse me. Then we do 4, boom, 0. That output would be 4. So what it's doing is it's comparing this, that output is 0, boom. We get rid of that right there. Then we're going to go with the 2s, boom, boom. That output would be 0 as well, so we get rid of the 2s. And now it's just 1 4 left, so it would be 4, boom, 0, and the output would be 4, and that's where the 4 comes from, guys. So that's how that works. That's how this bitwise that's how this bitwise exclusive OR operator works. And then let's clean this up a little bit, and after that, let's run it and see how it runs. So let's run it. Boom, and it's accepted. So let's submit it, and see if it stays accepted, because you know how that can go. And there it is, guys, 38 milliseconds, 96.15% of users with Swift beats 96.15% of users with Swift, guys. Now that's what I'm talking about. That's what I like to see. It's running faster than a Bugatti on an open highway, guys. And that's what we're talking about. That's what we're looking for. So I'll see you guys tomorrow for another day, another LeetCode problem. Peace.